You always
No, you gotta have it like 6 minutes.
well, yeah.
Okay, so we gotta look at economics problem. Okay, so and this is not real difficult economics, but it's a couple things you gotta know about setting up these calculus problems for economics applications. First of all, the most simple but probably most important economics equation is the profit equation. What's profit? Anybody know? Money? Well, no, it's actually not. The money you make is called what? Revenue. Yeah, revenue is the money that's coming in. What's the money that's going out? Costs. And profit then must be
What's left?
yeah, revenue minus cost. Right. So if R
Wait, oh.
I'm not ready.
R equals
That's what she did.
okay, that's profit. Okay.
Can you go back one?
What's that?
Can you go back one?
Go back.
Oh, no,
Go back to this. You mean right there?
Yeah.
we need to copy that.
What was the profit?
This is the problem we're gonna
P
do.
equals R minus
P equals R minus.
Okay, so we need to come up with. We're supposed to maximize profit. So we need to come up with a profit function. Right. That's our primary function. So to do that, we need to come up with revenue and find the costs and all that stuff. So a real estate office handles 100 apartment units. When the rent is $900 per month, all units are occupied. For each $45 increase, one unit becomes vacant. Okay? Each occupied unit requires an average of $55 per month for maintenance and repair. And then there's this fixed monthly cost of $6,500. Okay? So we want to know what rent in this situation should we charge to maximize the profit. Okay, there's another function you got to be familiar with too. This is called the demand function. Lowercase p.
No.
You get it?
Lowercase p is like the price per unit, and it's called the demand function. It's a function of x, where x is the number of units sold. Okay, and so we want to do is we want to from this information we want to establish what the demand function is, and then use that to maximize our profits. So it's got to be a function of x. If the demand function p is the price per unit and x is the number of units, how are those related to revenue? Think about that now. As an example, we're selling Calculus brand soup for $1 a can, and we sell 1,000 cans of it. How is that related to revenue? Revenue's money coming in, right?
So it's like what you charge times.
Yeah, it's just a product of the two, isn't it?
Yeah.
Right. So revenue is just going to be. That's not very good. So revenue just equals XP, right? Okay, but we need to come up with what the demand function is. The demand function, and there's a basic principle in economics. And I really don't have a huge economics background, but just enough to get myself in trouble probably. There's price versus you guys have probably talked about this before in your econ class. I mean, you guys have econ classes? No. Did you ever talk about anything economic?
I took an economics test at FBLA.
What'd you do?
I took an economics test at FBLA.
So there you go. There's the winner. Okay, so you're our economics expert. So you're going to lead on economics.
No, he knows everything about it. Trust me.
Okay.
He's smart.
All right. So the demand function. What typically happens to the demand for an item as the price goes up?
It goes down.
Goes down, sure, right? I mean, so there's going to be this inverse relationship. So we need to come up with our demand function based on the data points that we're given. Now we're going to assume that this is a linear relationship. If we had more data points, we could be a little more precise with that. And in the real world, we would do that. In the real world, what we try to do is we try to look at, we maybe do surveys, My cousin he has a company that does opinion research and surveys and stuff, and people pay a lot of money for him to go into an area and just sort of find out what people are willing to pay, for example, for stuff. And he'll call on the phone, he'll have them do stuff with Supermom. I mean, anyway, it's a long story, but so normally we'd have more data points than just these two, and if based on the data that we had, we could do like a regressional fit or something, do it with our calculators, right? We could put in the data and figure out what's the kind of curve that fits that trend the best, fit that to some mathematical function, and that's going to be our demand function. We're going to simplify this a little bit. We've only got 2 data points. So our data points are this. We know that when we charge $900 per month, we rent 100 apartments. For every $45 increase, 1 additional unit becomes vacant. Okay? So how could we turn that into, we could graph it if we wanted to. Sometimes it's helpful to think of things in terms of a graph. If I were to graph that, so let's say we could do, this is going to be kind of backwards, but we'll do P on this axis and X on that axis. How about? What are my data points then? When the price is 900, we get a certain number rented, right? When, so price is, like this, right? So something, say there's our point right there. So we get 900 for P, 100 for X, right? Make sense? If we, now I'm gonna skew this so we can see a little difference between the points, but if we increase the price by 45, the number goes down by 1. What's that sound like to you for a line? It's gonna go, isn't it gonna go down, right? So if the price goes up, the number rented goes down. So we have another point there, for example, that would be $945.99. Right, so as X goes up, as the independent variable goes up, the X is kind of mixed up here. As the independent variable goes up, the dependent variable goes down. Right, so we get a line, if I connect the dots here, like so. Right? Yeah, see, they're kind of backwards. Yeah, we could have done it the other way. But with the demand function, really you're kind of setting the price and seeing what the response is in the number of people that buy the item. So it probably, conceptually makes more sense to put P on this axis and X on that axis. It's unfortunate that it's an X. We're used to seeing an X down there. Okay. Does that make sense though? So the slope here would really be dx dp, wouldn't it?
Yes.
Okay. So this line represents our demand function. Right? This predicts, for a given price, this line predicts what the value of X will be, how many apartments are rented, right? So we just have to come up with the equation of the line, but that's not bad. We can do that stuff, right? So we got these 2 ordered pairs. What's going to be our, instead of y equals mx plus b, what's our slope-intercept form of a line going to be with our variables, p and x instead of x and y?
X equals M.
Yeah, x equals the slope, p plus b, where b is the y-intercept and m is the slope. What is the slope? Yeah, what's the rise between those 2 points? And we always go left to right.
45.
Say it again?
Negative 45.
No.
Oh, -1.
Yeah, so -1 over 45,
Yeah.
right? So the slope's -1/45. We can pick either one of these points to substitute into our equation to find b, right? We just need to find m and b. So if we plug, questions? Everybody okay? Okay. So if we plug this stuff in, then we get x would be 900 equals m, we said was -1/45, good, times p was 100, so let's put that on top, plus b. So b would just be 900 plus 145ths.
Yeah.
Does that make sense? So that'd be 92 and 10/45, so 92 2/9. Is that right?
Valentine candy for Elizabeth Casey.
Aww.
Oh,
Check
Yeah.
it out.
Yay! Love is in the air.
Yes.
Thank you.
Candy is here. Yeah, actually, so orange is in there.
Okay, no, we don't want to leave this as a mixed number though, right? Mixed numbers are for grade school, so we'll just make this an improper fraction. 92 times 9 is 100 and, what is that?
Yeah, how is it?
902.
902, yeah.
Not 90.
Oh, 902, you're right.
Okay, good.
Thank you,
Saw that
thank
too. I was like, oh god. That's what I was thinking.
Okay, so that's gonna give us what, 8,120 ninths?
Sure.
Yeah.
Okay, so then our,
Take it.
you better check me, I'm not exactly on the roll.
That's what he said.
I don't feel
What'd I say, 8,120?
You want a monster cookie?
Yeah.
That's right, isn't it? 8,100, yeah.
8,120.
I just tried it.
Yeah, I lost.
Okay, so there's our demand function, right? That predicts the number rented for a given price.
Did you make it?
So now we gotta complete our, so we know revenue is just gonna be X times P, right? Does that make sense? Oops, hang on, what did I do here?
I can't follow it.
What did I do here? I got it backwards, should be P equals M, that's right.
What?
I got that backwards, didn't I?
No.
No.
No, I didn't.
Somebody throw it.
Something doesn't look right there.
Yeah, how did we A1
It's all
share? That
through
doesn't
order,
look right.
we ought to just-
Oh, yeah, okay, yeah, I see it. Yeah.
Okay, you know what, I actually did this, I think I did this back, because we really wanna have P as a function of X. Not X as a function of P, so we need to solve I did it backwards, we gotta solve this for P. That's okay though, that's no big deal, we'll subtract this to the other side, right? Yeah, actually, how about if we just move this to the other side, subtract this, right, so we gotta do a little magic here. You tell me, what are we gonna get? If I put the P over here, because you see what I'm saying, I did that backwards, we wanna have, the demand function should be we should have price as a function of X. Yep.
Alright, I'm gonna understand it.
So we get, P is over here, we're gonna get 81/20 over 9 minus X times -45. So, correct me if I'm wrong here, you guys gotta be keeping a lookout.
With you. I mean, see, I can do the eye test, but that's what I can do.
Okay, this will work out well though, because when I multiply by -45, 45 over 9 is just 5, right? So I'm gonna get 5 times that, so minus
Oh, God.
4,620.
Yep.
Okay, so, is that right?
I got,
No, 4,600, right?
yeah.
Yeah.
Damn. Our mental math is running all over the place. It's like,
Okay, sorry about the confusion. Does that make sense though? All we did, so I really should have,
Oh, yeah.
I really probably should have put the P up here and the X down there, which would have been more convenient anyway, right? Okay. Did I mess that up?
Yeah, how is it?
Yeah,
what was-
8,000
times 5 can't be.
Oh,
46, yeah.
yeah,
I saw
sorry.
that too.
40,600, right? There we go.
Oh, my goodness. Oh, God.
Man, yeah, I'm just doing this to keeping you guys honest.
Keep it Make sure we're paying attention.
There you go. There you go. All these mistakes get kind of hot in here.
It is.
Yeah.
Okay, so there's our demand function, right? That's the price.
Sorry.
That's right. There's the price the price that's set for a given number of sales. So therefore, the revenue is just going to be P times X, right? Does that make sense? This is how much we're charging based on the number of
Oh, yeah.
items that are sold, right? So price per item, we said times number of items is revenue. Okay, so there's part of our profit equation. We're taking all this stuff, and revenue is just gonna be then XP, which is 45x squared minus 40,600x, right?
Yes.
Okay, what about our costs? Let's go up here and look at our costs. So the cost, it says we've got each occupied unit requires an average of $55 per month for maintenance. So what's that gonna look like then? Say it again? Okay, but it's 55 per unit.
You.
Okay, but U's not one of our variables. What are the number of units? What variable represents the number of units or the number of items, we said, I think? X, right? In this case, an item is a rental, I guess, right? So the cost then, part of it is gonna be 55x. That's the part that we'd attribute to maintenance fees, right? $55 for every rented apartment. Plus, what else? 6,500 is just a fixed cost for the whole complex. So we gotta add 6,500. So now we come up with our profit equation, right? Profit's just gonna be revenue minus cost.
Oh, cool.
Yay.
So,
Before
Yeah.
we're going further, how did we get the, why is it 45x squared? And like, where did those extra x?
He took the,
'cause we just multiplied P, I just distributed an X through, because it's X times P. Okay? So,
That is.
we get 45x squared minus 40,600x minus 55, we're gonna subtract cost, right? It's gonna be R minus C, so I'm gonna subtract all this stuff, so that's just gonna give me minus 40,000, boy, that seems like a really big number. Okay, seems large. Minus 40,545x.
600.
Oh, you're right, 655.
Thank you.
There we go. I should just have you guys come up and do this. Minus 6,500.
Yeah.
Wait, 65.
That's
what
Well,
you
it's
need
42,
to,
or
or is that what ours is?
Say it again. That's the whole thing, that's P. That's revenue minus cost.
Oh, that is pretty
Okay?
Big piece.
Two different.
Big P, yeah, right, big P. Okay, there's big P of X. So now, that's easy though, that's a polynomial, right? Now we've got this thing set up as a polynomial, the calculus is gonna be really simple, right? So that's the good news. There is some good news. Yes.
Take out
They do this.
or something like that.
I love it.
The numbers small. Okay, big numbers.
Something seems fishy about this though, that's a pretty big number. I guess we'll see. What's our domain gonna be? Remember, there were a total of, how many units, 100 units? So what's our domain? 0 to 100, sure.
40,000.
Yeah, we could rent 0, that wouldn't be very profitable for us, but
Never know.
in other words, we need to get some number on that scale somewhere. It could be that renting them all is our best bet too, we might find that. I don't know, I really don't know the answer, this is a new problem, so we'll see. I'm just as curious as you are, which I'm sure is very curious, right?
No.
So what's P prime?
90x.
Minus some big number, right?
Isn't it just?
40655. From off the last part.
Okay, so that is gonna be, wow, that's gonna be a big number. I gotta believe there's a mistake in there somewhere, but maybe not. We'll double check. If I set this equal to 0, where does this equal 0?
When x is 0.
Yeah, so that's gonna be,
4655 divided.
No.
it's gonna be more than 100 though, isn't it?
Yeah.
Right, because 100 times 90 would be 9,000. And so it's gonna be at a big number, right?
Super big.
More than 100, everybody agree?
Really big.
Okay, so
Yeah.
x, p, whoops, p prime equals 0 when x is greater than 100. That's all we need to know. We can only sell 100 of them, right? So then what's gonna be, if we take a second derivative, it's always positive, right?
Right.
So what's that, this has to be a mistake then. What's this telling us about,
There's no.
There's no.
It's not, yeah, not secret.
yeah, that can't be
It's
it.
all loss, yeah.
We gotta-
Yeah.
The economy.
It's pretty bad.
So I guess this demonstrates when things go wrong. We gotta go back and find out where things went wrong here.
The apartment industry is really scrappy nowadays.
Let it be. Let it be. Let these tracks-
Okay, let's, tell you what let's do. Let's
She looks so cute.
set up that graph again. I think something was wrong with our graph. So if we do P as a function of X, the cost, right? Demand function. Okay, what were our points were 900, 100, so it would have been 100, 900, right? When X is 100, that's an X. The price is 900, and let's see, when the number is gonna go down, so it's gonna be something like up here then, right? So we get a point, so this is gonna be 99, 945. Okay, so there has to have been something wrong with our line. I did some bad algebra there.
Yeah.
Yeah, okay, so we get P equals MX plus B. So our slope in this case is minus 45. Agreed?
Yeah.
Going from here to here, we're gonna rise by negative 45 and run by 1.
Oh, so it's not 140. I think that's right.
Yeah, just be 45.
No, we go left to right. So we start here, we go down, with the Y value, right? P goes from 945 to 900.
Oh.
Okay.
That's what happened. We had it flipped because it was 140.
Well, I think, but we had the axes flipped too, but I still think we made a mistake there. Okay, so, let's see, now if I plug in these values, I'm gonna get, P is 900, so I get 900 equals negative 45 times 100 plus B. So B would be what? 900
Minus-
plus 4,500, is that right? Yeah.
Yeah.
So we get 5,300.
Wow.
Okay, that's better. That's a better number.
I'll put it in.
I think it's 5,400.
5,400.
Yeah.
What is with me today?
It's alright. We all have our days.
Dude, it's Oregon's birthday.
Yeah,
It's just.
There you go. I'll blame it on that, I guess, man.
Yeah.
Okay, so our demand function.
Yeah.
So little p,
Is it negative?
Yeah, I know.
okay, much better, much better, right? There's our demand function. Okay, so we already did a bunch of the other work. Question?
What's that thing about the B equals 45?
That's supposed to be an arrow. It's not a very good arrow, but it's supposed to be an arrow and an X.
There we go.
There you go. Good question. Not a good sign. People are saying, what is that thing?
Good question.
Yeah, all right, so revenue.
We're learning new math today, it's not even calculus.
Okay, this is much better. This is much better. Yeah. Okay. That seems like that's how it should be. That's better. Okay. So then we had, and the cost was the same. Our cost was correct, I'm assuming.
Yeah.
Our cost was 55x plus 6,500.
Yeah.
Okay. So that's what we're subtracting, right? So we'll go back here, we'll pirate that from the last page.
Pirating's illegal if I know. We are done.
So profit, is revenue minus cost. Much better. Minus the quantity, 55x plus 6,500, right? So if we combine all the like terms, we get what? 5345. You better check me. I'm not on a roll.
Better check. Yeah.
It's 544.
Yeah, this is right there.
5345x when we add those terms up, minus 45x squared,
I'm gonna put that out there.
minus 6,500 is our profit,
Switch sides.
right? Okay, now let's go do our calculus again. That's much better.
Giant cat.
Okay, we got our domain, we said was 0 to 100. So what's P prime then?
Negative dx.
Okay, and as advertised, a lot of times the calculus ends up being pretty easy on this problem. Once you go through the hassle of setting it up, it's just polynomial. So this is going to be better. So this gives us a 0. This equals 0 when x is what? 5345 over 90, right? Which is better, because that's going to be something close to 60-ish, a little less than 60.
Yeah,
Right.
it's like 59.4.
59.4. Okay, so that's what.
What's your profit on?
No, this is the number of units that we're going to target per rental, based on our demand function.
So 59.
Yeah. So that seems kind of strange, but I just made these numbers up, so probably they're not very real world numbers. But that tells us that we'd want to have about 59 or 60 rented in order to maximize our profit, right? So, but what we really want to know is what's the price that we set to make that happen. So where do we go to find that?
Our boxed equation, well, we didn't.
Yeah, I don't know if we boxed it, we should have. It's our demand function.
Yeah.
Our demand function, I think, was back here, right? Right there. It is boxed. How about that? Yeah, there it is. There's the demand function. That's where we'll put the, what was it, 59.4, so we'll say 59.
Yeah.
Okay, so if we plug 59 in for X, we're gonna get what? Price is negative 45, somebody tell me what that is, times 59. What is it again?
Brian, you do the same thing.
Yeah, I got negative 2,000.
Net what?
Well, at least for the multiplication on that second, that's what you're asking. And then it's 2,745.
2,745, okay, there we go.
You're asking for the negative part of it, so it's okay.
Oh, okay, but then when you add this, you get, right, okay. So that's we're slumlords, I guess, that's a lot of money for.
That's what we should charge, right?
Yeah, that's what we should charge for rent.
Right,
Based
well,
on-
be able to make cookies.
Based on our data, that's what we should charge for rent.
Yeah.
Like I say, I kind of
We only have
numbers.
100 units.
Oh my God.
Alright, man, we're at top speed or something.
Okay, now that was kind of a fiasco, but you get the idea that, I mean, if you had some, can you see where this would be? You could do this, right? I mean, if you just had a few data points and you could just get that demand function, which frankly technology would do for you. That's something where you could just use regression, right? You could come up with, a real rationale for setting a rent price, for example. This is,
I don't know if he did
just so you guys know too, there is, obviously, money's not everything, but if you really want to make some money, being good at quantitative economic math is a big deal. People that do this kind of stuff as quantitative economists And they're paid literally, I'm not kidding, literally millions of dollars a year. Which would be a minor sum for these guys. They're called quants, and they employ them on Wall Street and in the financial markets on the East Coast. And they are just screaming for people like this. I mean, if you graduate from a good college with have performed well in an analytic area, physics or math probably primarily, even more than economics. They really just want people that can program, that are really good at math, and have good analytic skills, and they'll train you. They'll make you read a book over the weekend and learn the economics. But if you can do that stuff, you're fine.
You know what? I would just rather make $100,000 and not be stressed out.
But I tell you what, these guys I don't think are. I mean, I'm not trying to advertise this, but this isn't like these are the guys doing the buying and trading on the floor.
No.
All they're doing is they're just saying, okay, you guys want to give us the data. According to our data, you should be buying this many. They don't really have to go down there, and they're not the guys that are yelling at the top of their lungs on the floor. They're just making some decisions behind the scenes, pulling out their calculators and crunching some numbers, and they make just sick amounts of money. Yeah.
Are these the guys that design the computers that automatically trade the stocks? Because I know there's like a lot
Yeah,
of
right,
computers
they-
that trade
yeah.
that manipulate like up and down.
Yeah, yeah.
Yeah.
And it gets, just to give you a little idea about just how much people will pay for this slight advantage. This is where the buying and trading is done on Wall Street. The real estate around that area, like these previously impoverished neighborhoods, people are just paying millions of dollars for just like a closet-sized piece of real estate, so they can put a server there. So the server will be closer, so it takes the signal nanoseconds less to get to their computer than it does to people a little further away, and so they can have their preset trades ready to go, and they hit the floor earlier than people that are 100 yards further away. It's just crazy. It's absolutely crazy.
Did you see that on TED?
What's that?
Did you see that on TED?
No.
Because TED didn't talk.
Oh, huh. I didn't. Huh.
Is that what
That's
there?
No, there's like a.
Yeah, yeah.
Yeah, Mr. Lopez talked about that.
Yeah. So keep studying math, and you could make millions if you want to.
Yeah. They need it too.
Rebuttal, Pat.